excuse me. Next, I want to look at this. Now, s over s plus 1 squared plus 3. I'll write it out. S over s plus 1 squared plus 3 can be written as s plus 1 quantity minus 1, because s is of course the same as s plus 1 minus 1, over s plus 1 squared plus 3. And that's equal to what? That's just equal to s plus 1 over s plus 1 quantity squared plus 3. This is s plus 1 over that, minus 1 over s plus 1 squared plus 3. Now you might or might not see why that's important, but after you've used one of the identities that you find on the table a couple of times, you see that it is important. Okay? So what this becomes, this term becomes C times s plus 1 over s plus 1 squared plus 3 minus 1 over s plus 1 squared plus 3. Now over here I carelessly neglected to write my d out here. There's a d here, there needs to be a d here, and that's a little deformed. Okay, but then I'm going to have then plus d times 1 over s plus 1 squared plus 3. And I'll put a little wavy line in here to keep these things separate. And we see that I have negative 1 over s plus 1 squared plus 3 plus d times the same thing. Okay, so I have a negative of this plus d times this. Well, in the next step, I'm going to write this as d minus 1 times 1 over s plus 1 quantity squared plus 3. And I'm going to come back to white chalk here. And I'm going to write this as c times s plus 1 over s plus 1 quantity squared plus 3. Getting a little rough down here on the board, maybe getting a little bit difficult to read, but it should be pretty clear. And then we have a multiplied by s over s squared plus pi squared plus b multiplied by 1 over s squared plus pi squared. Now, it might not look like it, but I've now got all these terms in a format that's going to be easy to use with the table. Okay? This one clearly is the cosine of pi t. This one turns out to be 1 over pi times the sine of pi t. This one turns out to be e to the negative t times the sine of the square root of 3t, the cosine of the square root of 3t. And of course you got your c on here. We haven't evaluated these yet. And here you got your d minus 1, but this is then going to be 1 over pi, e to the negative t times 1 over pi times the sine of square root of 3t. Now I've just read those off to you. How in the world do I know that? Well, one way I know that is we worked it out a little bit earlier. Another way I know that is I know how to use the tables. Okay? And I remember what the inverse transforms. I think I remember. You know, I just committed myself to what they are. So if I'm wrong, go ahead and make fun of me. I've got very thick skin at this age. Okay, so I'm saying that this is going to be a times the cosine of pi t. This is going to be b over pi times the sine of pi t. Now I'm going to talk about how I know this. I'm going to talk about why I think this, at least. We'll see if I was right. And this is going to be then c e to the negative t times the cosine of the square root of 3t. That's this one. And this one is going to be d minus 1 over pi times e to the negative t, doggone it, I've lost that, e to the negative t times the sine of square root of 3t. That, and that are going to constitute our inverse transform, and those will be solutions to the equation. Now, right away, at this stage, you can easily verify that all these solve the equation. Well, actually, not necessarily these two. These constants, a and b over pi, where a and b are whatever we get from our partial fraction analysis that we haven't done yet, but that a and b over pi are going to have to combine with these things in a way that when we take the derivative of the sum of these two terms through here, we get sine of pi t. And you've done, we've tested over this. People did pretty well with this, problems of this nature. You can easily solve this problem and see exactly what I'm talking about without using Laplace transforms. Of course, that leads you to the question, why in the heck are we doing this? Well, we're doing this because this illustrates the process on something we know the solution of, and at the end here, we're going to do this with a square wave function that you don't know what to do with, because I'd even write a square wave function over here, and what in the heck is its derivative? Since it's not continuous, you're stuck. You can't do anything with that unless you do something really tricky. And there's something really tricky and also really neat that we can do with the Heaviside function to build the thing up and do this Laplace transform and all that. So we're going to do that. So that's why we're going through all the pain with this equation, which is much easier to solve using the standard methods everybody knows. Okay, now, I'm just claiming, just saying, that the inverse transform of this expression is e to the negative t times the cosine of the square root of 3t. Okay, now there's a little bit of a trick to that. The e to the negative t comes from the fact that you've replaced s by s plus 1, which shifts your graph 1 unit to the left, and that's going to give you an e to the negative t in a way you can kind of understand geometrically if we draw it out, and we might do that. We'll do it at least algebraically. Okay, and then over here, this is the same kind of thing as this, except you're going to get a sign because you don't have an s term up here in the numerator. And it's kind of neat the way this works out. Okay, well, let's talk about how we can establish what I just claimed and check out and see if what I claimed is actually true.